Alright, we're going to take another crack at the indicators video. I think this one's going to be a little bit better. Got a little bit more information on the screen for you. So, acid-base indicators are chemicals that tell you something about the pH level of the solution that they're in. So, while it's possible to buy something expensive like a pH meter, which is a very specialized device that you can dip into a solution, and it will tell you the pH based on that. Those are expensive and very finicky, and you have to maintain them in a particular way, and they're more hassle than they're worth a lot of the time. So something that we need to know for Science 30 is how to use indicators. And so up top here, you can see we have the indicator chart that you have from your Science 30 data booklet. And beneath that, I took an image from just Google image search of a couple of different indicators and the colors that they are at particular pHs. So we'll be able to cross-reference these two to learn about indicators. So the first skill that you need to know for indicators is figuring out what color a particular indicator is at a particular pH. So what we do is, let's say for example, we are looking at methyl violet. Boom. At a pH of 0, methyl violet has a color of yellow, and at a pH of 1.6, methyl violet has a color of blue. Now I know it says methyl violet is violet over here. It's a purplish blue color. So whenever the pH is above 1.6 on our chart, we would say that the color of methyl violet is blue. So let's take a look at another indicator. Let's take a look at thymol blue. So thymol blue, when the pH is below 1.2, has a coloration that is red. This one actually matches nicely with our color chart here. And when the pH is above 2.8, it has a color of yellow. If you look on the actual color chart that we have, if you are between those colors, or sorry, if you're between those pHs, you have an intermediate color, which means that, yeah, if we had, for example, a pH of 2, I'd say that that's between red and yellow, therefore it's orange. So the way the chart works is whatever color is on the left-hand side of the chart corresponds to the pH on the left-hand side. Whatever pH is on the right-hand side corresponds to the color on the right-hand side. And if you're in between those pHs, you simply have an intermediate or in-between color. So one thing that you may be asked to do is determine the colors of different indicators at a particular pH. So let's take a look at a solution that has a pH of 4.8. Now, this chart can sometimes give people a little bit of grief. I'm just going to go through a couple of the indicators here just to get a sense of how they work. So at a pH of 4.8, let's take a look at our buddy methyl orange here. Below 3.2, methyl orange is red. Above 4.4, methyl orange is yellow. And so since if our solution is pH 4.8, we can conclude that methyl orange is going to be yellow. If we look at the next one down, bromocresol green. Bromocresol green has a pH range from 3.8 to 5.4. Below 3.8, it's yellow. Above 5.4, it's blue. So since 4.8 is kind of in the middle there, that would indicate to us that it'll be an intermediate color. So we can say bromocresol green is green. One more just to kind of drive the point home. If we look at chlorophenol red right here, the pH when chlorophenol red is below 5.2 is yellow. So we can conclude that chlorophenol red is yellow. A chart like this, I mean, it's nice for another reason. What we can do with a chart like this, and I do believe that this is a little bit more user-friendly than the chart that you guys get, unfortunately. But what I could do with this chart is basically draw a vertical line around 4.8, and then we can just bang these out, like boom, 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 boom. So methyl violet would be blue or violet, thymol blue would be yellow, bromothymol or bromophenol blue would be blue, methyl orange would be yellow, bromocresol green would be green, methyl red would be reddish orange, bromothymol blue would be yellow, thymol blue would be yellow, phenolphthalein would be colorless, and alizarin yellow would be yellow. So we can just pick a pH and then it will slot right in there and we can find out what color everything's going to be. The second kind of question that you're going to run into is something along the lines of this. They might give you a number of pHs, or sorry, a number of colors of each different kind of indicator, and you have to use those in order to solve a possible range of pH. So if I do something like this, if I say bromothymol blue is blue, phenol red is red, and phenolphthalein, and I typed it out wonderfully this time, not like last time, is colorless, what is the pH of this solution? What is the possible range? This is where we're going to break out a number line, and that's why I have a number line down here from 0, the lowest possible pH, to 14, the highest possible pH, and of course 7 smack in the middle. So what I'm going to do is I'm going to draw out what pHs satisfy each of these conditions. So first we look at bromothymol blue is blue, and bromothymol blue is blue when the pH is greater than 7.6. So I'm going to just kind of guesstimate it here. I don't have to be perfectly right on, and the reason why is going to be obvious in a moment. So here is roughly 7.6, and I'm going to use the tools that I have at my disposal and make a nice little arrow. So that means whenever the pH is above 7.6, bromothymol blue has the color of blue. What about phenol red? Same idea. So we're gonna get phenol red, and phenol red is red above pH of 8. So I'm going to draw another vertical line and another horizontal line saying when the pH is above 8, my phenol red has a red color. And then the last one, phenolphthalein is colorless. Obviously I can't make a colorless line. I'm just going to use this darkish purple. And so 8.2 is kind of about there. And then I'm going to draw a line to the left. Because remember, phenolphthalein below 8.2, as illustrated here. So I'm going to pretend to be not very good at this. I'm going to make a mistake. I'm going to look at this and say, hey Lorenz, I'm thinking that the pH of the solution is probably, I don't know, 5.1. How do we check to see if we're right? Well, we go through all of these and we check what color each pH indicator is at that given pH. So at pH of 5, what's bromothymol blue doing? It's yellow. So we're wrong. Just for the sake of argument, what color is phenol red at pH 5? It's below 6.6, so it would be yellow. Wah, wah, we're wrong again. And phenolphthalein is colorless. Phenolphthalein is colorless below 8.2. So yeah, phenolphthalein at pH of 5 would be colorless, but the other two are wrong. So here's what we need to do. We need to zoom in on the spot where all three of the lines are overlapping. And I'm going to use a bright green kind of highlightery type of drawing here to show you where that area is. And so in that little sliver between pH of 8, because that was from our phenol red, and pH of 8.2, that was from our phenolphthalein, between those pHs, all of these indicators will give us the correct color. So let's just go through them one more time. So now I'm saying I'm pretty sure that my pH of my solution is between 8 and 8.2. So let's just say 8.1 is a possible answer. So let's see, bromothymol blue, what's it doing at pH 8.1? It's above 7.6, so it's blue. Boom, we got one right. What's phenol red doing at pH 8.1? Well, it's red as well, so that's correct. And what color is phenolphthalein at 8.1? It's below 8.2, so it's colorless. So I would say oops, 8 and 8.2. And that gives us the possible range. So all you're doing is you're looking at these pH values and you're selecting the ones that match up the colors, and where all three or all four of the indicators have overlapping lines on your little number line for pHs, where they all overlap is your correct answer. So sometimes the range might be bigger, but here it's nice from 8 to 8.2. That's a relatively tight range.